In our previous video, we covered the concept of algebraic fraction, in which we define an algebraic fraction as simply any fraction that consists of variables. We also play around with some variables in which we did some arithmetic operation with variables such as addition, subtraction, multiplication, and division as the case may be. In today's video, we are going to take some examples to solidify our understanding of what algebraic fraction is. In our previous video, we defined algebraic fraction as any fraction containing variables. We listed some of the examples of algebraic fraction, such as when we have x over 2y, 1 over x, 2a over b. As far as there is a variable at either at the top or at the bottom, we say that that is an algebraic fraction. So let's take some examples to solidify our understanding on algebraic fraction. Let's start with addition operation. Let's take an example. If we have 2 over 3y added to 3 over 4y, simplify. The question says we should simplify this problem. Now, to simplify this problem, notice that this is an algebraic fraction. Why is it called an algebraic fraction? Because it contains variables. A way of recognizing an algebraic fraction is that every algebraic fraction is simply a fraction that contains variables. So here, let's go ahead and simplify. The same way you tackle problems in fraction is the same way you tackle this algebraic fraction. Let's say we have a fraction 1 over 2 added to 1 over 3. To solve this fraction, the first step is to find the LCM of the denominators. So we take 2 and 3 and find their LCM. What can go into 2 or 3? 2 go into 2 will be 1. 2 cannot go into 3, you bring it down. So the next thing that can go is 3. 3 go into 1 is 1. 3 go into 3 is 1. So the LCM is simply 2 multiplied by 3, which is what? 6. So having gotten the LCM, which is simply 6, the next step is to draw a division line and drop your 6. Then you start the division process. So what we do, this is the LCM 6. So what we now do is we take each of the fractions and multiply them by the LCM. So we take the first fraction 1 over 2, we multiply by the LCM 6 over 1. We drop our addition sign. We take the next fraction 1 over 3, multiply by the LCM 6 over 1. And then we simplify. In simplification process, notice that when you have a multiples of 1 multiplied by 6 divided by 2 multiplied by 1, notice that 2 can divide 6 and you have what? 3. And then what you have is 3 times 1. So that's what we do. Go ahead and divide 2 here. 1, 2 into 6, you have 3. So what I have here is 3 multiplied by 1. And 3 times 1 is what? 3. We bring down addition sign. Then what can go? 3 here, 1. 3 into 6, you have what? 2. 2 multiplied by 1 is what? 2 over 1, 6. So when you evaluate that, you have 3 plus 2, which is what? 5 over 6. So that is how to simplify a given fraction. Now the same approach is used when dealing with algebraic fraction. So let's quickly implement that in the problem. So to solve this, we simply take the denominators and find their LCM. So let's take them aside. We have 3y and 4y. So to simplify this, to find the LCM, we simply deal with the numbers first, leaving behind the variables. So in dealing with the numbers, you know that 3 can go into 3, you have what? Y left. Now, 3 cannot go into 4y, so you drop it there as 4y. Now, to deal with 4, you go into 4. 4 cannot go into y, bring it down. 4 go into 4 is 1. So what you've left with is y. Now we have only variables left. The only thing that can divide variable is a variable. Variable y can go into a variable, you have 1. Variable here can go into this, you have 1. So the LCM is simply 3 multiplied by 4 multiplied by y. And when you have 3 times 4 is what? Is 12 multiplied by y, which is going to be what? 12y. Good. So now we have gotten our LCM, which is 12y. Now let's go ahead and simplify. So we draw our line and drop our LCM 12y. So we pick each of the fractions and multiply it by the LCM. So we pick the first fraction 2 over 3y and multiply it by the LCM 12y over 1. We drop our addition sign. We pick the next fraction 3 over 4y, multiply by the LCM 12y over 1. The next step is to do what? Simplify. So notice that y can take care of y here as just 1, 1. 3 can take care of 12, you have what? 4. So now we can multiply. 4 multiplied by 2, you have what? 8. So what I have here is 8. 4 times 2 is 8. We drop our addition sign. Then we go ahead with the next number. Y, take care of y is 1, 1. 4 can cancel 12. You have 3. 3 times 3 is what? 9. 9 divided by what? 12y. And this is equal to 8 plus 9 will give you what? 17 divided by what? 12y. And that is the answer. So let's take another example. Feel free to pause the video. That's how to tackle problems involving algebraic fraction. So what you need to do now, from this little illustration, from this example, you can see a pattern. And what is that pattern? The first step is take the denominators and find the LCM. So find the LCM of the denominators. That's the first step. And after which, take each of the fractions. Take the fractions and multiply by the LCM. And then you simplify. Then the next stage is what? Simplify. So that's the little step that are involved when tackling problems on simplification of algebraic fractions. So let's take another example involving this strategy. So let's say we have a problem. Let's say 1 over a plus 1 added to 1 over a minus 1. Okay, before we solve this problem, there is an interesting concept we need to talk about, and that is the concept of algebraic expressions. Algebraic expressions. What is an algebraic expression? An algebraic expression is simply a mathematical statement that involves letters, alphabets. So let's say you have A, B, C, D, etc. Any of the alphabets, A, B, C, D to Z, you see them in mathematical expressions. Then we call it an algebraic expression. Let's say you have A plus B. This is an algebraic expression. Let's say you have A squared. This is an algebraic expression. Even when it combines with constants such as numbers, even when you have something like 3a, 3x, 4 over 3y, anytime you have a number combining with a letter, it is still algebraic expressions. But there are 4 different kinds of algebraic expressions. Now, it is very interesting for us to understand these 4 different kinds of algebraic expressions so that we know how we go about problems like this. So the first kind of expression is the expression whereby the terms involved are just single terms. And what I mean by single term is that the single term can be a single number, just like 1, 2, 3, 4, or a single alphabet such as A, B, C, D, to Z, this one to N, or a combination of numbers and letters bounded by a factor of multiplication such as 1A, let's say 2A, 2B, 2X, or 5 over 4Y, etc. So anytime you come across anything like this, we call these single terms. And single terms in algebraic expression is called monomials. Monomials. These are single terms. Now, anytime you have a single term in an algebraic fraction, notice that in a given algebraic fraction that is written as x over y, our concern is the denominator. And we said the denominator must not be equal to what? 0. It must not be equal to 0. And in the same vein, the denominator determines what the fraction is. If the denominator contains single terms such as 2, or alphabet such as A, or combination of the two such as 2x, or something like x over 3y, we don't pay attention to the numerator. The numerator can contain anything. But once the denominator contains single terms, we call this type of fraction a monomial fraction. Just like the first example we solved. The first example we solved is simply an example of 2 monomial fractions being added together. Now, looking at this example here, This example is a different kind of fraction. Notice that the denominator is nothing like this. The denominator is a combination of two variables or two numbers or two constants bounded by a factor of addition or subtraction. Now, what do we call this type of fraction? Now, anytime you come across fractions that contains combination of two variables, either a variable alphabet such as a plus a or a minus b, anything involving variables, or a variable and a constant being added together such as a plus 2 or 2a minus b. Anytime you come across two different terms bounded by addition or subtraction, we call it binomials. 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 And anytime you come across fractions containing this kind of expression, we call it a binomial fraction. So looking at these two examples that I have here, these two examples are called binomial fractions. Binomial fractions. It is important that we understand this concept because I call it a very interesting concept that we need to figure out. Now, in the same vein, when you come across three different terms joined together by addition or subtraction, we call it trinomial expression. Such as if I have something like this, let's say we have a plus b plus c, different terms joined together by addition or subtraction, maybe even a combination of number, let's say 3x plus 2y plus 5z, or x squared plus 2x plus 3. Somebody will say this is x and this is s. Notice that this one is s squared and this is x. Two of them are not the same thing. So this is a different term, a different term, a different term. So because we have three different terms joined together by addition or subtraction, we call this type of expression trinomial. Trinomial. And anytime you have a fraction whose denominator contains any of these, this or this or this, containing three terms joined together by addition or subtraction, we call that type of fraction a trinomial fractions. And when you see a fraction containing terms that are more than 3, we call that type of fraction a polynomial fraction. Let's say we have a fraction like this, 3x plus 2 divided by ax cubed plus 2x squared plus 4x plus 5. Now notice that this contains 4 terms. 1, 2, 3, 4, bounded by addition or subtraction as the case may be. Now if it contains more than 3 terms, we call it, this is a polynomial fraction. This is a polynomial fraction, and so on and so forth. So in the same vein, it is important to understand these few basic knowledge whenever you're dealing with fractions, because it will help us to tackle the concept of LCM very well. So let's quickly solve this problem. Back to the problem. So to solve this problem, notice that this is a binomial fractions. So we take the denominator and find the LCM. So we take a plus 1 and a minus 1 to find the LCM of this. Notice that this is binomial expression, and whenever you are dealing with LCM, constants will divide constants, monomials will divide monomials, and binomials will divide binomials. Similar vein, trinomials will divide trinomials. So when we have binomials, so you know that only binomial can divide binomial. A cannot divide A because A plus B cannot be separated, neither can they be joined. They are taken as whole. So what can divide this is simply a plus 1. And when a plus 1 divide a plus 1, you have 1. And then you bring down a minus 1. What can divide a minus 1 is simply a minus 1. And when that happens is 1 and 1. So the LCM is simply the multiple of the denominators. So we go ahead and do that. So the LCM, we draw a line and put down the LCM, a plus 1 and a minus 1. So let's pick each of the fractions and multiply them by the LCM. So we pick the first fraction, a over a plus 1, multiplied by the fraction, by the LCM, a plus 1 and a minus 1, everything over 1. We drop our addition sign. We take the next fraction, 1 over a minus 1. We multiply by the LCM, which is a plus 1 and a minus 1 divided by 1. So we go ahead and simplify. Notice that a plus 1 will take care of a plus 1, and you're left with 1 multiplied by this. And anything multiplied by 1 is that number. So when we say 1 multiplied by a minus 1, you're left with what? A minus what? 1. So let's put it here. So we say 1 multiplied by a minus 1, you are going to have a minus 1 here. Plus, notice that a minus 1 will take care of a minus 1. So when this happens, you are left with a plus 1. And when a plus 1 multiply 1, you're left with a plus 1 here. Everything divided by a plus 1, a minus 1. So we simplify. So to simplify further, we simply need to take off the brackets of the numerator. So let's take off the bracket of the numerator. When we do that, we have a minus 1. Notice that because there's an addition sign here, this will not really be affected much. So you simply write it the way it is. Assuming that there's a subtraction sign here, we simply use the subtraction and multiply each of the terms in this binomial, and we write down what we have. So we have an addition sign, so nothing is much will really happen. Plus addition plus a will give you addition a, addition multiplied by addition 1. You simply have a plus times plus is plus. So you bring down 1. Everything divided by a plus 1, a minus 1. So we go ahead and simplify the numerator, collect the like terms. So let's collect the like terms. We can see that a is here, and there's a brother here plus a. We bring them together. What we have here is plus 1, and minus 1, we beat it. And everything divided by a plus 1 and a minus 1. So let's go ahead and add that up. We have a plus a will give you what? 2a. 1 minus 1 is already 0. So we have 2a divided by a plus 1 and a minus 1. And that is the answer. So that is how to simplify a given algebraic fractions. So notice that we've seen a pattern here. What is the pattern? Anytime you are asked to find the LCM of different terms, different expressions, you simply do what? Multiply the given expression. So if I have x and y, the LCM of x and y is simply xy. The LCM of x plus 1 and x minus 2, provided that they are different terms, you simply do what? Multiply the terms a plus 1 and a minus 2. So they will multiply each other to have this. So if you have a different terms as the LCM, if you want to find the LCM of different expression, you simply do what? Multiply the given expression. So feel free to pause the video and tell me the LCM of this expression. If I have, what's the LCM of x, comma, x plus 1 and x squared minus 2? What's the LCM? Notice that these are different. So without worrying your head, the LCM is simply going to do what? X multiplied by x plus 1 multiplied by x squared minus 2. And when that happens, you are going to have x into x plus 1 into x squared minus 2. That is how to find LCM of variables or algebraic word expressions. Now let's take a look at some problems on subtraction operation. So let's take an example on subtraction operation. So let's say we have 5 over x minus 1 minus 6 over x minus 2. How do you tackle this problem? Step 1, find the LCM. Notice that x minus 1 and x minus 2 are different expressions. So their LCM is simply their multiple. So you simply multiply these two expressions. So they are binomial. So these are binomial fractions. So the LCM is going to be x minus 1 multiplied by x minus 2. So the next stage is pick each of the fractions and multiply them by the LCM. So we pick the first fraction, 5 over x minus 1. We multiply by the LCM, which is x minus 1 and x minus 2 divided by 1. We drop our subtraction sign. Take the next fraction, 6 over x minus 2, and we multiply it by the LCM, which is x minus 1 and x minus 2 divided by 1. So we'll go ahead and simplify. So to simplify this operation, we are going to have x minus 1 here. We'll take care of x minus 1. What is left? X minus 2. And then we now have x minus 2 multiplied by 5. We're written as 5 into x minus 2. We drop our subtraction sign. X minus 2, we take care of x minus 2. We are left with x minus 1. And then x minus 1 multiplied by 6, we write it as 6 into x minus 1. And everything here is divided by the given LCM, which is x minus 1 and x minus 2. So let's go ahead and simplify. So to simplify the numerator, remember what I told you, anytime a constant is multiplying a binomial, you simply take the constant, multiply each of the terms in the binomial expansion. So let's go ahead and do that. 5 multiplied by x, you have what? 5x. 5 multiplied by minus 2, you have what? Minus 10. You bring down what? Remember, then we move to the next stage. You bring down what? Minus. Now we go 6 times x will give us what? 6x. Notice that because of minus here, this minus will multiply the minus that is inside here. So minus multiplied by this minus, you have what? Plus. And then 6 times 1, you have what? 6. And everything here divided by the LCM, which is what? X minus 1 and x minus 2. So let's go ahead and collect the like terms. To collect these like terms, we simply do what? Collect it. Notice that this one has x and this x. We bring them together. We have 5x minus 6x. So what do we have? We have minus 10 plus 6. And everything here is divided by the LCM, which is x minus 1 and x minus 2. So next stage is still on the simplification process. We go ahead and subtract. 5x minus 6x. What do we have? We have minus x. Notice that 5 is less than 6. So when you subtract 6 from 5, what will be left is a minus 1. So that is why we have minus x. So minus 10 plus 6 will give us what? Minus what? 4. Divided by what? X minus 1 into x minus 2. So this can be written as what? We can take the minus aside and we have this as minus, open bracket, x plus 4 divided by x minus 1 into x minus 2. Notice that if writing this thing like this simply means that when I expand the bracket, I said minus times s, I will still have minus x, and minus multiplied by plus will give me what? Minus, and we'll still have minus 4. So this is the final answer. So feel free to pause the video and try this problem out yourself. So let's say we have 2x over 3 into x plus 1 minus 3x into 2 into x minus 2. Feel free to pause the video and try this problem out yourself. Remember, the first step is to do what? Remember, this is, we take the denominators and find the LCM. To find the LCM of the denominator, notice that they are different times. We simply was multiply them together. So to multiply the terms, we have the LCM will be what? 3 into x plus 1 multiplied by 2 into x minus 2. So that's it. Now when we multiply when we expand this out, what would we have? We multiply constant by constant and binomial with binomial. So what do we have? 3 multiplied by 2. That is 3 times 2. We have what? 6. So we'll rewrite this as 6 into x plus 1 x minus 2, and that is the LCM. So we go ahead and take each of the fractions and then multiply by the LCM. So let's go ahead and do that. Take the first fraction, 2x over 3 into x plus 1 multiply by the LCM, which is 6 into x plus 1 x minus 2 over 1. We draw our subtraction sign. Take the next fraction, 3x over 2 into x minus 2 multiply by the LCM, which is 6 into x plus 1 x minus 2 divided by 1. So we go ahead and simplify. So to simplify this given operation, we are going to have what? So let's go ahead and simplify that. This is 3x. So this is x. So let's go ahead and simplify. Notice that 3 can take care of 6 and you have what? 2. X plus 1 can take care of x plus 1. You have x minus 2. So what I have left is 2 multiplied by 2x will give what? 4x multiplied by x minus 2, which is written as 4x into x minus 2. Then we drop our subtraction sign. We do the same for here. So 2 into 6 here, you have 3. X minus 2 into x minus 2, you have x plus 1. So 3 here multiplied by 3 here, you have 9x into what? X plus what? 1. So, and everything here is divided by the LCM, which is 6 into x plus 1, x minus 2. So, we go ahead, still on the simplification process. We simplify the numerator. So to simplify the numerator, what we do is simply take what is inside and multiply whatever thing that we have in there. So let's go ahead and do that. So to simplify the operation, we said 4x multiplied by x. Here we have what? 4x squared. 4x multiplied by minus 2. Remember, this is, we are dealing with what? Variable here. X times x will give you x squared. The constant 4 remains where it is. Then 4x multiplied by 2. Remember, we're dealing with numbers now. The x will remain where it is. So we have minus 4 times 2 is what? 8. So the x remains where it is. That is 8x. So what do we have left? Minus. This minus multiplied by plus that is here still minus. So you have minus. 9x multiplied by x is, remember, it's only variables that are multiplying. X times x will give you x squared. The 9 remains where it is. So you have 9x squared. So 9x multiplied by 1, only 9 multiplies 1, and you have what? 1. So remember, minus times plus will give what? Minus. So 9x times this will give what? 9x. And everything divided by what? 6. It multiplied by x plus 1, multiplied by x minus 2. So we go ahead and then simplify the operation at the top. So to simplify the operation at the top, we collect the like terms. So to collect the like terms here, what do we have? So let's go ahead and collect the like terms. So notice that we have x squared here and x squared. Collect them together. We have 4x squared minus 9x squared minus 8x minus 9x. Everything divided by what? 6 into x plus 1, x minus 2. So, collection of like terms. So let's quickly simplify that and get what our operation will be like. So let's go ahead. 4x squared minus 9x squared. Because they are having x squared and x squared, 4 minus 9 will give you what? Minus 5. So we have minus 5x squared. Then what do we have here? Minus 8x minus 9x. Because of minus 8 minus 9, we give us what? Minus 17. So you have minus 17x divided by what? 6 into x plus 1 into x minus 2. We can simplify this denominator, but it's better we deal with the answer like this. So this becomes the final answer. Okay, let's take another example. Feel free to pause the video and try this problem out yourself. So let's say we have a plus 3 divided by a minus 3 minus a minus 3 divided by a plus 3. Question says simplify. To simplify this operation, notice that these and these are different. So the LCM is just their multiples. So you simply write here the multiples, which is a minus 3 multiplied by a plus 3. So we begin the process. Take each fraction and multiply by the LCM. So we take the first fraction, which is a plus 3 divided by a minus 3. And then we multiply it by the LCM, which is a minus 3 into a plus 3. Everything divided by 1. Then you bring the subtraction sign. We take the second fraction, which is a minus 3 over a plus 3. And then we multiply it by the LCM, which is what? A minus 3 and a plus 3 divided by 1. So we go ahead and simplify the operation. And when we do that, notice that from this given expression here, that a minus 3 here can take care of a minus 3. And you're left with what? A plus 3 and a plus 3, which will be written as a plus 3 multiplied by a plus 3. And then you have subtraction sign here, minus. Notice that a plus 3 can take care of a plus 3. You're left with what? A minus 3, a minus 3. So you have minus a minus 3. Maybe use another ink there. Minus. You have a minus 3, a minus 3. And everything is divided by a minus 3, a plus 3. So that's it. So let's continue with the simplification operation. Now the next stage is to do what? Is to get rid of the brackets. at the top and at the bottom, if you, as the case desire. So to multiply out what is there, anytime you're multiplying two binomial fractions, two binomial expressions, such as, let's say we have a plus 1 and a plus 2, if you're multiplying these two binomial expressions, the rule simply says take the first variable, the first term, and multiply the first term of this. Now take the first term, multiply the last term, and then when you're done with that process, you take the second term here, multiply the first term here, and take the second term here, multiply the second term here, and then you have your expression. So let's quickly implement that and let's see where it gets us. So we start with the first process. So here we go, we have a multiplied by a, we have a multiplied 2 times, that's a squared. Then a multiplied by plus 3, you have plus 3a. We are done with the first process. Then the second process, we have 3 multiplied by a, we have what? Plus 3a. Then 3 multiplied by 3, we have what? Plus 9. So we are done with the expansion. So with this minus the same process here, you have a multiplied by a, here you have what? A squared. A multiplied by minus 3, you have minus 3a. Minus 3 multiplied by a, you have minus 3a. And minus 3 multiplied by minus 3, those are minus as minus will give you plus. 3 times 3 is what? 9. And everything here divided by the LCM, which is a plus 3, sorry, a minus 3 and a plus 3. So next stage is to take off the brackets. So let's do that. First step, let's collect the like terms, simplify it. So to do that, we have a squared, 3a plus 3a will give you what? 6a plus 9. Remember, this minus multiply everything inside the bracket. So let's go ahead. Minus times a squared give you minus a squared. Minus times minus 3a give you plus 3a. Minus times minus 3a give you plus 3a. Minus times plus 9 will give you what? Minus 9. Everything here divided by what? A minus 3, a plus 3. And notice that 3a plus 3a will give you what? We simply give you what? Plus 6 what? A. So let's go ahead and simplify further. To simplify, we simply collect the like terms. So let's collect the like terms. Notice that a squared we meet minus a squared here. So we have a squared minus a squared. So what's the next guy? 6a we meet plus 6a here. So you have plus 6a plus 6a. What do you have next? 9 we meet minus 9. So you have plus 9 minus 9. Everything divided by a minus 3, a plus 3. So what do we have next? We have it that a squared minus a squared will give us what? Everything here will give us what? 0. 9 minus 9 will give us what? 0. So what we left with is 6a plus 6a. And 6a plus 6a will give us what? 12a. 6 plus 6 is 12. A plus a is still a. So you simply have 6a plus 6a. You have what? 12 what? A. Everything divided by a minus 3, a plus 3. And that is the answer. So that's it for addition and subtraction operation in algebraic fraction. Now the next operation we're going to look at is multiplication operation. In multiplication operation, the principle is very simple. The same way, anytime you have an algebraic fraction and you want to, that you are asked to multiply this. So let's take an example. Let's say we have something like 8 over 2x multiplied by x cubed over 3. How do you solve this problem? Sorry, x cubed over 4. How do you solve this problem? To solve this problem, anytime you are multiplying two algebraic fraction, the rule says multiply the numerators and multiply the denominators and cancel as when required. So this becomes equal to 8 multiplied by x cubed divided by what? 2x multiplied by 4, which we can expand this is 8 multiplied by x cubed means x multiplied by x multiplied by x 3 times, and then 2x means 2 multiplied by x multiplied by what? 4. So notice that 1x can take care of 1x, 2 can take care of 8 here, you have what? 4. 4 can take care of 4, you have nothing left. So what we have is x multiplied by x, and x multiplied by x 2 times means x squared, and that is the answer. So let's take another example involving multiplication. So let's say we have 2a plus 3 divided by a plus 1 multiplied by 3a plus 2 divided by a plus 2 multiplied by, let's say, multiplied by a plus 1 a plus 2 divided by 3a plus 2. How do we solve this problem? This involves multiplication. So the rule says just multiply everything on the numerator and multiply everything on the denominator. So to multiply the numerator, we simply have 2a plus 3 multiplied by 3a plus 2 multiplied by a plus 1 multiplied by a plus 2. And everything here is divided by a plus 1 multiplied by a plus 2 multiplied by 3a plus 2. So we look out for anything that can divide each other. So notice that from the look of things here, a plus 1 will take care of a plus 1, a plus 2 take care of a plus 2, 3a plus 2 take care of 3a plus 2. So we are left with what? 2a plus 3. And that is the answer. Remember, each of these is 1. This can be expressed as 2a plus 3 over 1, which is something as 2a plus 3. And that is the answer. So when it comes to multiplication, the rule is simple. Multiply the given term. Even when you have x6 divided by x multiplied by x over y. To deal with this is simply, let's say, divided by x over. To deal with this, you know that x to the power of 6 means x multiplied 6 times. Multiply 6 times. Multiplied by another x divided by x multiplied 2 times. Multiplied by what? Y. Notice that 2x will take care of 2x. Well, how many x do you have? 1, 2, 3, 4, 5. So you have the answer being x raised to the power of 5 over what? Y. And that is the answer. That's how to deal with multiplication operation. So let's cover the concept of division operation. In the case of division, the rule says anytime you have problems on algebraic fraction involving division, what you simply do is to change the division sign to multiplication sign, and when you do that, the position of the other fraction will be changed. So let's say we have a given problem. Let's say I have 9 over 6x divided by 3 over 4x. How do we tackle this problem? So the rule says change this division sign to multiplication sign, and when you change the division sign to multiplication sign, this variable, this fraction here, interchanges its position. So when we do that, we have that this is 9 over 6x multiplied by, this can be rewritten as 9 over 6x multiplied by what? This goes up, this comes down, so you have 4x over 3. So then we expand as usual. This is 9 multiplied by 4x, 4 multiplied by what? X. Everything divided by 6 multiplied by x multiplied by 3. Notice that x can take care of x. 3 go into 9, you have what? 3. 6, that is 2 can go into 6, you have 3. 2 can go into 4, you have what? 2. And then what can go? 3 can go into 3, you have 1 and 1. So what I have here left is just 2. Only 2 divided by 1. So I have 2 over 1, which is something as what? 2. And that is the answer. So whenever you have division sign involved, you simply do what? Change it to multiplication sign, and then you divide. So let's take another example. Let's say we have a plus 1 divided by what? 2x. And then this is divided by a plus 1 squared divided by 3x squared. So how do we tackle this problem? Remember, the rule says change the division sign to multiplication sign. So to do that, the other variable will change its position. So we have a plus 1 over 2x multiplied by, the whole thing changed. So you have 3x squared divided by what? A plus 1 squared. And anything squared means that they multiply 2 times. So this can be expanded as a plus 1 over 2x multiplied by 3x squared is same thing as 3 multiplied by what? X multiplied by what? X divided by a plus 1 squared means a plus 1 multiplied 2 times. So in that case, we can see what can cancel. A plus 1 can take care of a plus 1. S can take care of one of the x's. And what else is left? What we have here left is simply 3 multiplied by x, which is 3x, all over. We have 2 here. 2 multiplied by a plus 1, which is 2 into a plus 1. Is there anything I can divide? No, nothing. And this becomes the final answer. So that's gonna do for this video on algebraic fraction. I will see you guys in the next video.